Hi, today I'm going to do a lesson on more fraction subtraction. We actually started this lesson last week and we ran out of time. And so I went ahead and we need to finish that lesson, and I added on some word problems because I know that's another skill. Word problems, particularly ones with fractions, can be challenging. So again, I'm a tutor for the Seeds of Literacy, and my name is Ann Scanillo. So last week I told you, and same deal this week, many of the problems that I've taken from this lesson are from the 3 fractions packets that Seeds will be providing. So if you have any of the packets with these front pages, you know that you could flip through and find some of the same examples and some of the same problems.
Yes.
I want to review a little bit of the fraction vocabulary that we talked about last week. Fractions, as we talked about, is actually just a part being compared to a whole. And the part is always listed on top of the fraction, and the whole is always listed on the bottom. The part at the top is the numerator, and the whole at the bottom is the denominator. And then we also talked about some other vocabulary terms, for instance, proper fractions. Proper fractions are fractions that are written in the regular formatting, and the top number, or the numerator, is always smaller than the denominator. But we also have improper fractions, and improper fractions are not incorrect or wrong answers. They're just answers or fractions that are written in a strange way. And if you complete a problem and you wind up with an improper fraction, even though your answer is correct, it is still customary and you are still expected to turn that into a mixed number, not an improper fraction. So mixed numbers was our next vocabulary term we talked about. That's when you actually have a whole number together with a fraction. We also talked last week about equivalent fractions, and that's a really important concept when you're talking about either adding fractions or subtracting fractions. We talked about this is a square, pretend like it's a cake, and we have 1/4 of the cake is shaded. But here's the same cake. It's exactly the same size, but instead of dividing it into 4 pieces, it's divided into 20 slices. So we can see this time if we have 5 slices out of the total 20, we're actually eating the same amount of cake as we did in the first illustration where we ate 1 slice out of 4. And then same thing. If we took the same cake and divided it into 100 pieces and we ate 25 of them, it actually has the same value. It's the same amount as 5/20ths of the cake and 1/4 of the cake. Common denominators. We talked a lot about common denominators. Whenever you subtract fractions, the denominators, that's the number on the bottom, must be the same. So their example, 8/9 minus 7/9 equals 1/9. And we did some simple problems like that last week. And need to advance. Okay. Unlike denominators, because a lot of times this happens, we've got, in order to be able to add or subtract, you have to have the bottom numbers, the denominators, the same. And we do that by finding the least common multiple of that denominator. Get it to advance. There we go. Now, Taylisha, we actually did this practice last week. It was a little strange, so I wanted to review part of it. So can you tell me, do you remember if we had 1, or that's a whole, and it's going to be equal to, how many thirds would that be equal to?
How many thirds?
Yes.
Talking
about this one right up here. So we have a whole, and I'm going to have to regroup that because I'm going to need common denominators. I'm going to have to learn to rewrite fractions. So 1 whole could be written as how many thirds?
1 whole And division is how many? 1/3? I don't know. I don't think I understand what you're saying. Oh, right. 3/3. Right.
And it's
Oh,
weird. The reason
okay.
you missed it, and it was the same last week when we did it, the reason you missed it is because 3/3 is an improper fraction, and we just are not used to seeing fractions written that way. It looks strange to our eyes and to our brain. But in order to be successful subtracting fractions, we have to understand, and we're going to have to be able to rewrite a whole as 3/3. So how about
Right.
I had to write a whole as fourths? How many fourths would that be?
4/4.
That's it. And how about as twelfths? How would we, sometimes it just doesn't want to advance for me. Okay, how many twelfths? A whole would be how many twelfths?
12/12.
That's it. Okay, now the second row, to my eye, these seem even stranger. But again, it's a skill turning 3 wholes into 2 wholes plus a certain number of 8. Being able to rewrite that to have the same value is going to be important when we have to subtract. So can you do that one for me? 3 equals 2, and how many eighths?
8. 8/8.
You're awesome. That's it. And how about 2 equals 1, and how many thirds?
2 equals 3. 3/3.
You're awesome. Perfect. How about 5 equals 4, and how many 6?
5. 6. 6/6.
That's it. Perfect. Now, this is another review page that we did last week, and I thought, before we get into too much of the subtracting, I wanted to just practice the idea of reducing the fraction. So we just practiced writing whole numbers a different way. Now we're going to practice taking fractions and then putting them into their reduced form. So they already told us that 3/9 equals 1/3. And honestly, I'm not sure if we're going across or, let me peek. There we go. We're going down. So 4/10, we have to divide the 4 and the 10 both by 2. So what would the reduced version of 4/10 be?
What? Say that again.
So we have 4/10 right here. And if we were to reduce 4/10, means we're going to divide the top and the bottom both by 2.
Oh, 2/5.
You're awesome. That's it. How about 12/20? Can you reduce that one for me?
Yeah. 3/5.
You did the same thing last week, and that was perfect. That is not the first answer I get from most students. Most people would say, oh, I can divide 2 into the top and the bottom, but then they have to divide by 2 again. You're good with your multiplication facts, and you know that 4 divides evenly into 12 and 20. So you just saved yourself a step.
Thanks.
How about 4/8? What's that as a reduced fraction?
A half.
It is a half. How about 8/12?
2/3.
Perfect. And 8/10?
4/5.
Yep. All right. So sometimes we're going to have unlike denominators. And the first example to review, because we did talk about this last week, is actually an addition problem. So the example problem is 2/5 plus 1/4, and they don't have the same denominator, or the bottom number is different. So we have to find a number that could be a denominator for both of those fractions. And that lowest common multiple of 5 and 4 is 20. They likely got that number by saying 5 times 4 is 20. So I know both of those fractions could scale up to 20ths. So then they said I would just have to multiply 2/5 times by 4 over 4 would be 8/20ths. I could rewrite 1/4 by scaling the numerator and the denominator both up 5 times. I would get 5/20ths. And then I could just add 8/20ths plus 5/20ths to get 13/20ths. Okay, so we could have done a subtraction problem the same way. So I want to see if you can do it using subtraction. So now we have 2/5 minus 1/4. See if you can solve that on your own. Did you remember to rewrite them with a common denominator?
Yes, I'm trying to do it in my head. The common denominator would be 20.
You are awesome.
And then the new fractions would be 8/20 and 5/20.
Yes, it would be.
And the new fraction would be 3/20 because you would subtract it.
Absolutely perfect. So how about 3/20? Can we reduce that?
No, because there's no factor that goes. The number 3 does not go into 20 without a remainder.
You are absolutely correct. Nice job.
Thank you.
Okay, so now we have another one. 4/7 minus 1/3. See if you can do this one. First of all, what's our common denominator going to be? Because they have different denominators. So what is the number that both 7 and 3 will both divide into evenly?
21.
Nice. So see if you can solve it.
Okay. 1 would be, so it would be 12 over, it would be 12 over 21 okay. Wait, because I'm doing it in my head, so sorry.
You have no pencil and paper again?
I do. I was in the process of moving and trying to.
Hey, Tylisha, you're all good. I wasn't being critical, but remember last night I remembered I can be your secretary. I'm happy to be your secretary.
Okay.
So you just told me that 4/7. Remind me again, what was 4/7? You turned it into a denominator with the denominator of 21. What was it going to be?
12 over 21.
Nice job. And so now you've got 1/3. And you need to put that, okay, here we go. I'm your secretary now. Can you see that?
Yes.
So we have to turn 1/3 into 21sts. How many would we have?
7. 7 over 21.
Nice job.
Thanks.
So now we're going to write our problem as 12 over 21 minus 7 over 21.
And it would be 5 over 21.
If I can get it to advance. And the answer is, oh, I'm sorry, we're not finished yet. 5 over
over
21.
21.
Nice job.
Thanks.
I have to try to get everything, squeeze everything onto my screen here. Okay. So now here's another one. 11/15 minus 3/5. So I can be your secretary again. What's your common denominator going to be?
The common denominator is 75.
75
But I'm
absolutely
thinking it can be.
positively would work. But there's a much easier way to do it.
Yeah. I'm trying to think what it is. Is it 15?
It is 15.
Yeah.
Remember last week, and I almost reviewed that slide, but I didn't put it back up. Now I wish that I had. They had a strategy, and they said you would put the 15 and the 5, and you would list all the multiples. And so then we would say like 15, 30, and 45. And then for 5, I would list the multiples. It'd be 5, 10, 15, 20. And then we would keep going on. And then we would say, what's the smallest number that appears in both lists? And we would say, wait a second. There's a 15 in both of those lists. So my lowest common denominator would be 15.
Mm-hmm.
All that to say, 5 divides evenly into 15. So we can just leave that one alone and turn 3/5 into 15ths. So let me see, we're going to leave 11/15 alone, but we need to turn 3/5 into 15ths, and it looks like that. So how many 15ths would that be? 3/5 is how many 15ths?
3/5 is 1.
Not
1/15.
quite. 5 times by what would be 15?
Oh, times 3.
Nice. So that means we're going to have to scale the top or the numerator 3 times bigger. What would that be?
9.
That's it.
9 over 15.
Correct. And I usually, for my students, I'll write it like that to show that, okay, I'm getting cockeyed. If 5 was multiplied by 3 to get to the 15, you're going to have to do the same thing on the top. And so 9/15 is correct. So now we're going to subtract 11/15 minus 9/15. What would that be?
2/15.
That is it. Nice job.
Thanks.
Okay. So we did these last week. I'm going to have you practice them again. You were pretty strong with them, but it's been a long time since last week, and fractions can be weird. 5/6 minus 1/3. Can you solve that one? What would our common denominator be? Taylisha, I've got the top fraction.
I'm sorry. The phone was muted. I'm sorry. Our denominator would be 18.
But that would work. But there's a much easier way to do it. There is a lower common multiple that both 6 and 3 divide into.
Oh, 6, right?
It would be 6. So help me rewrite that problem.
Okay. Okay. What we should get to 5, 6 times 1, and 3 times 2. times 2. You would rewrite the problem to 5 over 6 and 2 over 6.
Correct.
And it would equal 3/6, which is a half.
You are awesome. 3/6, and you did know to reduce it, and it was 1/2. The next problem is 9/10 minus 3/5. So you can tell me again, what's our common denominator going to be? 10 and 5 are our denominators. What's a common number they both divide into evenly?
Would it be 10?
It would be 10. So how are we going to rewrite this problem?
Give me 10, 1, be 9. So it would be 9 over 10
Good.
minus.
I'll do it. I'll be your secretary again.
Okay.
Might be easier to see. I know we're visual creatures, and so it might be easier to see. You've got 3/5. How many tenths would that be?
6/10.
That's correct. So we would rewrite the problem as 9/10 minus 6/10. What's that going to equal?
9 minus 6 is 3/10.
Nice. And how about, can I reduce that one at all?
No.
Nope, you cannot. Let's try this one. 15/16 minus 7/8. What's our common denominator going to be?
16.
Nice. You didn't get tricked on this one. So we're going to 15/16 the way it is. But we have to turn 7/8 into 16ths. Whoops. Okay. So what's that going to be?
Be 15 over 16.
Look at that one again.
Okay.
Try it again. 15/16 is not quite correct. I mean, you're close, but that's not correct.
Okay.
Look at the bottom. 8 times by what equals 16?
2.
Nice. So that means 7 times by 2 is going to be how much?
14/16.
That's it. And so we could rewrite the problem as 15/16 minus 14/16. So what's the answer to this problem?
1 over 16.
Nice. That's it. I think it showed. Yes. Good. Okay. This is another review thing. This was a screen we had last week. It just was so strange. I wanted to just show it one more time. So our problem said that we need to subtract 2/3 from 5. And the way we would write this problem is like this: 5 minus 2/3. And notice how they have the 5 is a little bit to the left of where they wrote the 2/3. They did that to give us room. You know, we have all of our whole numbers lined up and all of our fractions lined up. We need a fraction. So we need to divide the number 5 into a whole number that is put together with a fraction. And we have to do that so that we have a way to subtract the fraction of 2/3. This was that practice page we did a few minutes ago. We rewrote 5 as how many thirds, and we could have rewritten it as 4 3/3. So now that it's rewritten, we subtract 2/3, and our answer is 4 1/3. Okay, so that was a lot from last week. This next screen we also talked about. This is even more confusing, or it can be. Our problem is subtract 2 3/4 from 6 1/4. So I wrote the problem to the right of the screen just to show you our starting point. We're supposed to be doing 6 1/4 minus 2 3/4. Our problem is that 1/4 minus 3/4, we can't do that because we're not allowed to work with negative numbers in this situation. And we don't have enough. If I had 1/4 of a pizza and I had to take away 3/4, it's impossible. So I have to borrow from my whole number of 6. And so you can see that they rewrote over here where I underlined in purple. Instead of writing 6, they rewrote that as 5 4/4. So then they say, well, let me see, we actually had 6 1/4. So if I rewrite it as 5 4/4 plus 1/4, that's going to be the same thing as 5 5/4. When we practice, it'll probably make more sense. So now our problem is 5 5/4 minus 2 3/4 equals 3 2/4. You reduce the fraction part and it becomes 3 1/2. Okay, so now we're going to practice some of these. And actually, I remember we did these. This was like the very last thing we did last week. But and I remember being impressed because you did really well with this group of problems. Let's see how you do this time. We have 3 1/4 minus 3/4. So I want you to try to solve that. And if you need me to be your secretary, tell me what to write and I'll hold it up so you can see it.
Okay. We need to make them wholes, right? This was the part I kept getting confused on.
It's hard. That's why I thought we need to practice these again. Okay, so our problem is we want to subtract our fractions first, and then we're going to subtract our whole numbers. But we can't subtract our fractions because 1/4 minus 3/4, that's impossible. That would be a negative number, and we can't have negative numbers in this situation. So I need to borrow from my 3 wholes, from my whole number of 3. I need to borrow some fourths. So what's another way to write 3? I could write it as 2 and how many fourths?
2 4/4.
Nice. But we have another fourth to add to that, another 1/4. So how could I rewrite this number? So you told me we had 2 4/4. And then we're going to add, here we go. We had 2 4/4, and we're going to add another fourth. So how would I write that?
2 4/4.
Well, we've got that at the top here. But now we need to add another fourth because remember, originally we had 3 1/4. So what's 2 4/4 plus another fourth?
2 5/4.
That's it. And I think I can show you what that looks like on the screen. 2 5/4 is correct. That's just another way to write 3 1/4. We needed to do that to get enough fourths to be able to do our subtraction. So 2 5/4 minus 3/4. What's that going to be? We subtract our fractions first, and then we subtract our whole numbers. So what's 5/4?
It would be 2 1/2.
Nice job. And it would be actually 2 2/4.
2 2/4.
No, but your brain knew that's the same as 2 1/2. And that's the proper way to write it, would be 2 1/2. Nice job. I told you to get, you just have to get warmed up on these. We just have to practice a little bit. Yeah, because these are weird. Okay, now this one, I remember you doing this one because you got it so quickly, and I didn't expect that. It's 5 minus 2.5. And again, I have to subtract my fractions first, and I don't even have a fraction at the top. So what am I going to do?
You will make it a whole. So it
Okay.
would be 5/5.
But we need
Oh,
common
to be
denominators.
2.
Okay.
Oh, okay. Okay, so we can do 4 and 2/2.
You're awesome. That's it. I told you were really good at these, and I was surprised at how strong you were with this skill. Okay, you're right. It's the same thing as 4 and 2/2 minus 2.5. What's that going to be? So we
2
subtract the fractions.
and 1, 2 and it would be 2.5.
It would be 2.5. Nice. Good job. Okay. So the next one, yeah, we're finished with the review. So this is all new material. We're almost finished with the different types of problems, and then we'll get into word problems. Okay, so we're dealing with subtracting mixed numbers. And so they're showing us that our problem, they want us to subtract 2.5 from 7 3/8. And so we have to write the problem down first. So I've put a box here. So we would write that as 7 3/8 minus 2.5. We need the same denominator in our fractions, and we don't have that. So they rewrote for us. It becomes 7 3/8 minus 2 4/8. So they just rewrote the same problem over here. So now we need to 3/8 minus 4/8. Well, I can't do that because I don't have enough eighths. I need to rewrite 7 3/8. I'm just going to rewrite the 7 first. I'm going to write that as 6 8/8 plus 3 more eighths. So it's like 6 11/8 minus 2 4/8. And our answer is 4 7/8. Did you keep track of all that, Taylisha?
Okay.
Okay. So now, wait, let's see if the lettuce. There we go. Okay, so now we're going to try to practice it. So we have 9 7/8 minus 5 3/4. So we have to subtract our fraction part first, and we need a common denominator. What's our common denominator going to be?
Our common denominator is going to be 32. No, it's going to be 8.
Perfect.
Yeah.
Perfect. But you know what? I should have done an example because I can't tell you how many times the student says 32, and you can work the problem that way. It absolutely would work. It's just going to be more steps. You're going to have to reduce this big fraction later on. If you can see that 8 is the common denominator, that's going to be easier. So we've got 7/8, but we have to rewrite 3/4 as eighths. So what's that going to be? 3/4 equals how many eighths?
3/4 equals 6/8.
Nice. And so we can rewrite the problem. We had 9 7/8 minus 5 6/8. So what's that going to be? What's that answer going to be? Subtract the fractions first, and then we'll subtract to the whole numbers.
That's going to be 1/8. So it would be 4 and 1/8.
Perfect. Okay, so this one, it's a little bit uglier. 15 1/4 minus 10 1/2. Going to subtract our fractions first, and they don't have the same denominator. So what's our lowest common denominator going to be?
4.
Nice. So that means we're going to have to rewrite 10.5. And so actually, let's just rewrite the fraction part first, okay? So 1/2 would be how many fourths? So 1/2.
1/2 will be 2/4.
Nice. It would be 2/4. Okay. So we could rewrite that. Let me see if I've got it in there that way. Good. So we could rewrite this problem as 15 1/4 minus 10 2/4. So can you solve it from there?
Mm-hmm.
What do you think? Subtract your fractions first.
5 and 1/4.
Okay, wait a second. Oh, no. Nope, you got tricked this time. Let's go back. Let's look at just the fractions. We have to do 1/4 minus 2/4. Can we do that? If I have 1/4 of a pizza, can I take away 2/4 of the pizza? It's impossible.
No, it would be a negative.
It would be a negative. And we can't work in negatives in the middle of a problem like this. So what am I going to have to do? I need more fourths. I only have 1/4, and I need more of those fourths so I can do my subtraction. Where am I going to get more fourths from?
The 15?
Nice. It would be the 15. So we're going to have to rewrite 15 a different way so that we have some more fourths. What's that going to look like? 15 would be the same thing as what?
15 would be the same as 3/5.
No.
No.
You're getting tired. Okay. 15, remember, we're going to rewrite it as a whole number plus some fourths.
Okay, so it would be 14 and 4/4.
That's it. That's exactly what I was writing. Perfect. Okay. So now instead of thinking 15 in your brain, you need to be thinking, well, that's the same thing as 14 and 4/4. Now look at the screen. We have an extra fourth here. So can you add one more fourth?
Add one more fourth.
Yeah, so we're at 14 and 4/4 plus another fourth. How much would that be?
15 and 5/4.
You're really close. You're right. 1/4 and 4/4 equals 5/4, but we still just have the 14. The reason this skill is so challenging is because we're making our brain work backwards, and we're making it put the numbers in a really strange, improper form. We have to do that so we can subtract, but our brain prefers to see 15 and 1/4. It doesn't like to see it written 14 and 5/4. So you're just causing your brain to work backwards. But that's where we're at.
Okay.
We're at 14 and 5/4, if I can get the screen to advance. We're at 14 and 5/4. And now we need to subtract our 10 and 2/4. We'll advance. And so what's that going to be? Now we can subtract our fractions and then subtract our whole numbers, and we can actually solve the problem now.
Okay, 4 and 3/4.
That is it. I think. Oh, wait. Yeah, there it is. Perfect. Okay. That was a really hard problem. I think that was our hardest problem of the whole day. So, and we survived, so that's a good thing. We're going to look at some word problems now, and they're all fraction word problems. So again, I can be your secretary. You're going to tell me what to write. It says, the clerk at Valley Fabric cut 4 1/3 yards of cloth from a bolt of fabric containing 9 2/3 yards. After she removed this piece, how much fabric was left on the bolt? Okay, I'm going to read it again. And you're thinking, what equation can I write to help me solve this problem? So that's what you're going to tell me is the equation, and I'll write it down. So it says the clerk at Valley Fabric cut 4 1/3 yards of cloth from a bolt of fabric containing 9 2/3 yards. After she removed this piece, how much fabric was left on the bolt? Think about your equation.
Okay, so we know it's going to be okay, the clerk at Valley Fabric cut yards of from a containing after she removed. Okay, so it would be 4 1/3 minus. No, it would wait. After cost of yards of containing. Oh, okay, so it would be 9 2/3 minus 4 1/3. Is that right?
Yes, it is. And I think I have to remember what I put on the screen. I think I've got it on the screen too. That's it. 9 2/3 minus 4 1/3. You did a lot of good things. After you heard the problem and then after you read it yourself, you knew it was a subtraction problem, and that's a skill in itself. And then you also knew you had to take the total minus the part that was cut off. Okay, so now can you solve that one? On the screen, I wrote it.
Yes, you can.
There we go. And there it is.
It would be 5 1/3.
That's it. And the correct answer, I can't even see. Does it show the answer? Yes, 5 1/3. Nice. Oh, and so because it's a word problem, we always have to show the answer in sentence form. So 5 1/3 of cloth were left on the boat. Okay, so let's try another one. Joe's pickup is able to carry 7/8 ton of rocks. Frida's pickup can carry 3/4 ton of rocks. How much more rock can Joe's pickup haul in each load than Frida's? So Joe can carry 7/8 ton. Frida can carry 3/4 tons. How much more can Joe's pickup haul in each load than Frida's?
This would be another subtraction problem.
Nice. Okay. What would it be?
And it would be 7/8 minus 3/4.
Perfect. So go ahead and solve that for me.
Okay.
Or if you want me to be your secretary, tell me what to write.
Okay. So we need 8 as our common denominator.
Mm-hmm.
Then we need times 1. So we have 7/8 and 6/8. And we would subtract it, and it would be 1/8.
That's perfect.
So
fantastic.
So 1/8 tons more.
That's it. Joe's truck can haul 1/8 ton more rock in each load. Good job. Okay, let's try this one. Jeff weighed 166 pounds. He went on a diet and lost 11 3/4 pounds. How much did Jeff weigh after his diet?
We would have to make a fraction out of the 166.
Good. Yes, we would. That's exactly what we would have to do.
And it would be 165 and 4/4.
Yes. Oh, okay, so that was the original problem. Nice. Okay, keep going.
Then it would be 154.
Oh, are you solving the
And
problem in your head?
yeah.
Tell me what it is. Okay, look at the screen. I've got the original equation was 166 minus 11 3/4. You
Mhm.
had me rewrite 166 as 165 4/4. So now we'll just rewrite that. Here we go. 165 4/4 equals 11 3/4. Now go ahead and solve it, and now it'll make sense to my brain too.
Okay. Okay, 1/4. Okay, 164. No, wait. Minus 65. 154 and 1/4.
Perfect. Nice.
Thanks.
So in complete form or in sentence form, what would our answer look like or sound like?
154 and 1/4 pounds.
Okay, that's our answer. The question was, how much did Jeff weigh after his diet? So how would we write that answer in complete form?
Okay. Jeff weighed 154 and 1/4 pounds after his diet.
You are an amazing student. Nice job.
Thanks.
Okay, let's do this one. Mary ran 2 3/4 miles on Monday, 3 3/8 miles on Wednesday, and 1 5/8 miles on Friday. How many miles did Mary run in the 3 days? So tell me what you need me to write.
Okay. Okay, so we just need to change the common denominator of 3/4 to match the denominators of 3/8 and 5/8. So the new fraction would be 6/8. So it would be
Nice.
2 and 6/8 plus 3 and 3/8 plus 1 and 5/8.
You cannot be tricked. I threw in an addition problem because there are going to be people that say, oh, wait, everything's subtraction, and they would have written it as subtraction. We are combining. So this is an addition problem, and you knew to change the denominator. You already rewrote it like that. So now from there, go ahead and solve that problem.
Okay. Um, 5, 6 and 9 plus 9 to 12. 6 and 14 over 8, which is improper.
Good. Okay, hold up. Your brain works in a different order. 6 and 14/8. That doesn't look right. We're going to have to rewrite this. See if you can do that.
How do you multiply?
Nope. We're doing the opposite of what we were doing on those last couple of really hard problems. Well, we have 14/8. That's an improper fraction. So we need to, don't worry about the 6 for right now. So think of 14/8. We need to write that as a mixed number. So we can take out a group of 8/8 and turn that into one whole. What would that be?
A group of 8/8.
Yes, so you're going to take that out and rewrite that as a whole number 1. I'll write it like this. So what's 14/8 minus 8/8? How much is left after we take out one whole?
6/8.
Nice. So it looks like that. And I think I also have it on the screen over here. So you see what we did? We took 8/8 out of this fraction. So it wouldn't be an improper fraction anymore. And we added that whole to our whole number over here. So that became 7. There was still 6/8 left. Are we finished with this problem?
No, because you can reduce that to 7 3/4.
That is correct. Nice job. So the question was, how many miles did Mary run in the 3 days? What would your answer be in sentence form?
Mary ran 7 3/4 miles in 3 days.
That is exactly what Mary did. Nice job. I'm pretty sure this is the last problem, so you're doing great.
Thanks.
Now, this is the second half of Mary's running problem. It says, Mary tries to run 10 miles each week. How many more miles does Mary need to run to complete the 10 miles? And remember, from the last slide, we saw so far she's gone 7 3/4 miles. She wants to run a total of 10. How many more miles does she need to run? So tell me what.
You would have to convert the 10 to a fraction. So it would
Okay,
be
before we even do that, tell me what's the equation? Before we start solving it, what is the equation going to be?
then the equation is going to be 10 miles minus 7 3/4 miles.
That's it. Nice. Okay, so now go ahead and solve it. You knew we had to convert that 10. Go ahead and work it.
9 and 4/4 minus 7 and 3/4
Perfect. Go ahead and solve it.
is 1, 2 and 1/4.
You're awesome. And so what would be your answer in sentence form?
Mary has to run 2 1/4 miles more to complete the 10 miles.
Perfect. Absolutely perfect. And if I'm not wrong, that was our last problem. Good job.
Great.
Thank you very much for your time.